Good day everyone. Welcome to ICT Online Learning. For this day, so let us proceed to the next chapter that is about atomic structure. So for that, so let us start with the protons, electrons, and neutrons, which is what we call the elementary particles of the atom. So for the subatomic particles, so we have again proton, we have the symbol P+, then the charge is positive, relative mass is 2000, and for the location is at nucleus. For electrons, so we have E negative, the charge is negative, relative mass is 1, and the location of electron is orbit around the nucleus, or simply electrons are found in the shell. Then the last one class, so we have neutrons, so we have N0, and then the charge is neutral, and then the relative mass is 2000, then the location is at nucleus of the atom. Now, the mass number, also known as the atomic mass or atomic weight, and the atomic number from the periodic table are very important numbers because they tell us how many subatomic particles are contained in a given atom. The atomic number tells us the number of electrons and the number of protons. Example, so we have atomic number is equal to the number of electrons is also equal to the number of protons. And the atomic mass tells us the total number of particles in the nucleus. We have atomic mass is equal to the number of protons plus the number of neutrons. So that is how to identify the atomic mass. Again, that is the sum of the number of protons plus the sum of, or just plus the number of neutrons. So that is how to determine the atomic mass. Okay, now, for example, I have here an element that is a boron. Okay, so look, we know that boron is located in the periodic table with a given details. So we have the atomic number of boron, that is 5. Atomic mass is 10.18. Then the symbol is B. Now, what are the specification of the boron based on this particular table? So we have here this information for the element boron. So the symbol is B. Then the atomic number is 5. Then the atomic mass is 11. So we round up 10.81 to 11. And then since the number or the atomic number of boron is 5, so obviously the number of protons and number of electrons are 5 also. Now for the number of neutrons, so just simply subtract the atomic mass and the number of protons. So it will become 11 minus 5, that is equivalent to 6. So meaning 6 is the number of neutrons for boron. Okay? Now, another, so we have here the parts of an atom. So again, first one is the nucleus. Nucleus, that is the central part of an atom that contains protons and neutrons. Second, it is the center of an atom and it's made up of protons and neutrons connected through bonds. Third one contains most of atoms' mass. Next, how about the subatomic particles? So we have proton, that is a positively charged found within the atomic nucleus, discovered by Ernest Rutherford. Letter B, electron, that is a negatively charged, discovered by J.G. Thomson or Joseph John Thomson. And letter C, neutron, that is no charge or uncharged particle found within a atomic nucleus, discovered by Sir James Chadwick. Okay, so those are the parts of an atom, nucleus, at the same time the subatomic particles. As well as also we have the shells, or what we call the orbit. An orbit that contains electron traveling at the same average distance from the nucleus. Second, like a space or cloud around the nucleus. So that is shell. Now, other definitions. So we have isotopes, atoms of the same element that have different mass or atomic mass unit or AMU. And we have also angstrom. That is a common unit for describing the size of atoms. If we consider the amount of angstrom, so that is 1 times 10 to the negative 10 meter. So if we consider the scientific notation equivalent of that particular parameter, that is angstrom, again 1 times 10 raised to negative 10 meter. Okay, next. Some other definitions, so we have the atomic size, the region of space occupied by an atom electrons. Example is the atomic orbitals is the best, though of as a probability distribution of electron density, therefore there is no well-defined outer edge of electron density. Then we have also the atomic mass. The atomic mass, or M sub A, is the mass of a specific isotope, most often expressed in unified atomic mass units. Then second one, so the atomic mass is the total mass of protons, neutrons, and electrons in a single atom when the atom is motionless. Okay? Then the last one, so we have atomic number. Atomic number in chemistry and physics, so atomic number, also known as the proton number, is the number of protons found in the nucleus of an atom and therefore identical to the charge number of the nucleus. It is conventionally represented by the symbol Z. Then the atomic number uniquely identifies a chemical element. In an atom of neutral charge, the atomic number is also equal to the number of electrons. As we discussed earlier, so again, atomic number is equal to the number of electrons, is also equal to the number of protons. Okay, so that is the definition of atomic number. Okay, so for that, so thank you so much and thank you for watching and hope to see you in our next video. Good day everyone and have a blessed to everyone.
For more ICCT College's video updates, please subscribe and click the notification button.